Hi, my name is Leah Davis. This is my Fuel Science 431 project. It is actually a new discovery of a catalyst that converts CO2 into natural gas. It was discovered by Mark Koper, Jen Zhang at London University. Now, what is this and what drives this? This is actually a catalytic conversion of carbon dioxide to carbon monoxide and methane. As you learn in your introductory chem courses, a catalyst increases the reaction rate. Now, this catalyst increases the chemical reduction reaction of CO2 from carbon monoxide to methane. As you can see, the picture on the right is what this is a general idea of what this process is going to start with. Now, this is actually driven by cobalt porphyrins and immobilized on a pyrolytic graphite electrode, which is in an aqueous acidic solution and performed at relatively low voltage. Now, we can actually define this process as something. We would define this as an efficient electrochemical reduction, converting CO2 into a fuel of high energy density, natural gas, which is what we wanted. Thus, we are actually creating a neutral energy cycle. Now, what are the challenges faced? These challenges were actually huge, and the whole point of trying and process of figuring out what was going on. The number one problem was finding a catalyst that reduces CO2 but beyond 2 electron products. The normal products would have been carbon monoxide, formic acid, and oxalate, but this catalyst was needed to make a 4 electron to 6 electron product. Now, the other idea was that suppressing hydrogen, because it was dominating the actual reaction and it was not getting the products we wanted, by suppressing this, we would get products like methane and methanol, which is what we wanted. Now, as you see to the right, this is the actual cycle of what is going on in this catalytic conversion of CO2 to natural gas. And you'll see it's at a pH of 1 and at a pH of 3. Now, how does this work? What is the synopsis? Well, as you learn in your introductory chem courses, you know what photosynthesis is. And this process starts with photosynthesis. It is actually broken down into photosystem 2 and then photosystem 1, as you see on the right of a more descriptive way of how this works. Next, we intercept the reaction at photosystem 2 because, as we've said before, we were looking for a more electron-dense stage. And this is actually the most electron-dense stage in the process. Now, what we do at this stage is we insert a catalyst of cobalt porphyrin and an electrode of pyrolytic graphite to create the methane and methanol. And this would be all at a pH of 1 to 3 and at voltage of 0.5. Now, the main thing about this are the advantages of this besides just getting natural gas out of a renewable process, but that it is cost effective. Cobalt porphyrin is actually a part of vitamins B12, which can be found in local stores like Walmart, but also you could be taking on a daily basis. Now, the other great thing is that this graphite is actually homemade. It is actually a homemade electrode, which is similar to what is in your lead pencil, which is crazy because we use that on a daily basis as well. Now, another main advantage would be that it is renewable and it does create a neutral energy cycle, which is the goal of what we've wanted in a while. But not only that, it is treating the excess carbon dioxide that is into our atmosphere that we're producing that has caused a problem and is in the news for a while now, helping for global warming as well. But one of the main disadvantages that are being worked on right now is that there's no way to mass produce this yet. Now, what are the goals? The goal in this is to eventually be able to start and control this reaction by solar energy, making it 100% renewable. As you see on the picture on the right, this is what happens with a photovoltaic. Now, we want to be able to store and use this, and that's the main goal for this process as well. So you can see if you insert it between the solar irradiance and the panels, we could eventually be able to store this. In conclusion, I believe that this will revolutionize the renewable industry, that we should implement this at community levels and work our way up so that discoveries are made and we can make this into commercial use, but be able to use this as soon as possible. Thank you. These are my references, and I hope you enjoyed learning about this new catalyst.